Open your book to page 68. This lesson is to find directed distance from a line to a point. So you try to look for so you already learned how to find the distance between 2 points. So this is the distance from a point to a line. And page 69, it went through all the proofs and continue with the 70. So the result is on page 71. So let's go to page 71. So you have this equation over here. You have d equal to ax plus by plus c over plus or minus square root of a squared plus b squared. So d is the distance between the point and the line, and the point is your xy. The equation of the line is ax plus by plus c. And notice that the plus or minus. So the sign will go with whatever the sign for b is. So if b is positive, you get positive over here. If b is negative, you get negative. And once you calculate the distance, the final result is if the distance is positive, that means the point is above the line. If the distance is negative, that means the point is below the line. So let's go over some examples. Let's go to example 1. Example 1, it says find the distance between the line 5x equal to 12y plus 26 to the point p1 3 negative 5 p2. So these are three parts. So you have to do each one individually. So let's do the point 1 first. You have the equation 5x is equal to 12y plus 26, and p1 is 3 negative 5. P2 is negative 4, 1. P3 is 9, 0. So first you want to put this in the general form. So move this over. So minus 12y, minus 12y, minus 26, minus 26. So your equation would be 5x minus 12y minus 26 equal to 0. So let's go and do the 1. So I'm going to call this D1 for point 1. So D1 equal to 5 blank minus 12 blank minus 26. And the blank would be the point that you want to put in there. So 3, 5, so 3 negative 5. So the D1 is for point 1, so it would be 3 negative 5. And on the bottom would be, since this is negative, you're going to get negative. Right? You follow the sign of this negative. And this is a hypotenuse of that. So 5, 12, right away you know it should be 13. But if you don't get that, we just go 5 squared plus negative 12 squared. But you should know that it's, the 5, 12, the hypotenuse would be 13. Right? Think of this is your hypotenuse, right? So 5, 12, it should be 13. So if you know that, you can write it right away instead of doing it the wrong way. So D1 equal to 15 plus 60 minus 26 over negative, again you work out, again like I said, this is spatial triangle 5, 12, 13, okay, or you can just work it out. So D1 equal to, you work it out and you simplify, so you get 49 over negative 13. Again, negative tells you that the point is below the line. So you can look at the picture, you can see that the point 1. So if you look over here, see D1 is over here. So D1 is below the line. So that's why distance is negative. Okay, and you do the same thing for D2. So if you do D2, we're equal to 5 times blank minus 12 times blank minus 26 over negative, again it's 5, 12, 13. Right? And the D2 is for point 2, so it would be negative 4, 1, so it would be negative 4, 1. And you work it out, simplify, and you might want to do extra steps, so it would be negative 20 minus 12 minus 26 over negative 13. So D2 equal to negative 58 over negative 13, so D2 equal to 58 over 13. So positive distance means the point is above the line. Okay. So if you look at the picture over here, see the D2 over here, see the point is above the line. Therefore, the distance is positive. Okay, let's go to D3. So D3 equal to 5 blank minus 12 blank minus 26 over, again, 5, 12, 13. And remember the sign, the plus minus, it go with the B. So B is negative, so it would be negative. So D3, you put a 0.3 into the blanks, so it will be 9, 0. So D3 equal to 45 minus 0 minus 26 over negative 13. So D3 equal to 19 over negative 13. Again, negative distance means the point is below the line. So if you look over here, see the D3 is below the line. Next, let's go to example 2. Example 2, you have two parallel lines. You have 15x plus 8y plus 68 equal to 0. And you have 15x plus 8y minus 51 equal to 0. So you got two parallel lines. And you try to look for the distance between, you're looking for distance between the two lines. Okay. So there are two ways you can do this. So one way is find the distance between the origin. What you do, choose a reference point. Usually it's the 0, 0 is the best point. So what you do is find the distance between the origin to this line and find the origin to this line, and then from that you can find the two distances. Okay. And if you don't know how to sketch it out, but if you want to sketch these things out, the graph it looks like if we were to sketch it out, so it would look something like so this one would be something like this. Okay. So let's call this 1, let's call this 2. So this is 9, 1, and this would be 9, 2, would be something like this. So it would be 9, 2. So basically what you want to do, you want to use the point, and you want to find this D1 and find this D2. Okay? And from D1, D2, you can find out the distance between them. So that's one method. So use 0, 0 as your point. Okay. So D1 equal to 15 times 0 plus 8 times 0 plus 68 equal to positive. Now again, here's your spatial triangle. 8, 15, 17, right? Okay. If you don't get that, you can just go and use a square root. Use your Pythagorean theorem. A squared plus B squared. That's your C squared. So D1 equal to, again, work it out. You're going to get 68 over 17. So D1 equal to 4. Okay. And then you find D2, same thing. So D2 equal to 15 times 0 plus 8 times 0 minus 51 over 17. Right? D2, you have to use the second equation. Right? You're looking for D2 over here. Okay. So D2 will equal to negative 51 over 17. So D2 equal to negative 3. Okay. So again, negative means the point is below the line. Now, so once you got D1 and D2, right? To find the distance between them, you have to subtract. Just like when you have just like let's say if this is 2, 3, 4, 5, right? To find the distance between these 2 points, you have to use the end minus beginning, right? Use 5 minus 2, that's how you get 3, right? So you have to subtract. Okay? So you can, doesn't matter which one you subtract, you just take the absolute value of that. So the distance will equal to 4 minus negative 3. Right? Again, to find the distance between them, you have to subtract. And so distance equal to 7. Okay? So this is one method. Okay? Find the distance between the origin, the point to the line, the point to the line, and you subtract to find the distance between them. So that's one. So this is one option. The method 2 is to find a point on the line. So like this one, so the first equation is 15x plus 8y equal to 68, negative 68. Right, just move it over. So I can find a point. For example, if x equal to 4 and y equal to 1, right? So this is a bit harder because expression number is messy. So if you put 4 in here, you get 60, and put 1 over here, and you have to get negative, right? Okay. So negative 4, negative 1 is on this line. So you can use this point. So negative 4, negative 1. So this picture is not as accurate, right? So, but it's fairly close. So it's almost like over here. So that's your negative 4, negative 1. Okay. So now you can just go and use this point to this distance over here. See that? So in this case, so again, second method is find a point on one of the line and use that point to the other line. So distance would be equal to, you have to use this one here, right? So again, you want to use the point from here to this line. So it would be 15 blank plus 8 blank minus 51 over 17, right? Again, spatial triangle, a squared plus b squared equal to c squared, right? And now you have to use this point because this point is on this line. So you want to use this point on this line to this line over here. Okay? So use negative 4, negative 1. So distance will equal to negative 60 minus 8 minus 51 over 17. So distance equal to, use your calculator, you work it out. So this would be 9, and this would be 119 over 17 negative, right? So d equal to negative 7. But again, remember, negative just shows you that the point that you choose is below the line, right? And so again, but you're looking for total distance, so the net distance would be equal to 7. Okay. So you can use either method. So either method, it works about the same.